Hello, my dear old students. This is our ninth week of this semester, and in this week, I would like to describe some new things. First one is numerical integration, second one is trapezoidal rule, and third one is Simpson's one-third rule. All these are very important, and so please listen carefully and try to understand. Now let's start. At first, what is numerical integration? Numerical integration, it is a technique of calculating the numerical value of a definite integral. What is definite integral? Definite integral means there must be some ranges, and the given function must be follow the specific ranges, and we do the functions in integration. When f(x) or y is not known explicitly, but we are given only a set of numerical values of the function corresponding to some values of x. Okay, as we integration this equation on behalf of dx. The value of the function may be given at equidistant value of x or at non-equidistant value of x. Okay. There is a general quadrature formula which is given, and you can see that the general quadrature formula is I equals to h into n y naught plus n square by 2 del y naught plus n cubed by 3 minus n square by 2 del square y naught by 2 factorial plus up to nth term. Now, what are the purposes of general quadrature formula? Since fx is known at equidistant value of x, we can approximate fx by the Newton's forward interpolation formula. In general quadrature formula, we integrate the Newton's forward formula over n equal intervals. So I think it's clear. Now, numerical integration rules. There are some rules for integration. One is trapezoidal rule, one is Simpson's one-third rule, another one is Simpson's three-third rule. All the things, and also Bedel rule, all the method we can solve one by one, and in this lecture we only solve first two, that is trapezoidal rule and Simpson's one-third rule. Okay, now go to our next slide. This is the trapezoidal rule. Here, the area formed by fx is calculated by the sum of the area of n trapeziums. Hence, this method is known as trapezoidal rule. It may be clear if I explain it more precisely. This is a formula which is obtained by integrating over the sub-intervals, and then adding is called composite numerical quadrature formula. And from this composite numerical quadrature formula, we can get trapezoidal rules or trapeziums. When we put n equals to 1 and neglecting the second and higher order differences, we can obtain the following equation, which is the format of integral value x naught to xn and fx of dx or y dx, and we get h by 2 y naught plus yn plus 2y1 plus y2 plus y3 up to yn minus 1, where x naught equals to a, xn equals to b, and h equals to b minus a divided by n is the known form. As we know all the value of these, which we already discussed in Newton's interpolation formula, and n is the number of the sub-intervals. Okay, there is an example given for you which is solved by trapezoidal rule. The equation is find the value of 1 by 1 plus x square, and the range is between 0 to 1, and this equation is solved by trapezoidal rule. So let us consider the equation equals to y, where a equals to 0, b equals to 1, and n equals to 6. Okay, how we consider n equals to 6. Actually, we will divide the interval into 6. So we consider n equals to 6. It may be very depends on the equation. Okay, now let's go to our next slide. Here you can see that um, we calculate the value of h, and we just simplify the equation by subdivision. Okay, there are two columns. One is x and another one is y, which is the equation. At first, x equals to a, and a means 0, what is the initial range, which is already given in the equation. If we put this in the equation, then we get y naught, or first value of y equals to 1. Then we just calculate it up to 6th value of x, and we also get y value up to 6th term, and that will be 0.0, no, sorry, 0.5. Okay, this is the calculation is very simple, and I hope you already understand how the calculation did. Now, when you put all the values in the trapezoidal rule, then we will get our final results, and the result is 0.78424, which is where it is considered as the fifth decimal point. I hope all of you understand, and this rule is very simple, and there is no um, mm, difficulties, I think. Now, Simpson's 1/3 rule. Okay, in equation, if we just put the n equals to 2, and neglecting the third and fourth order differences, we can find h by 3 into y naught plus yn plus 2 yn plus y4 up to in this way. Or we can simplify this equation, which is h by 3 y naught plus 4y1 plus 4y2, where x and y's value, x naught and xn value already given in the equation, and h equals to b minus a into 1, and n is the number of subintervals. So the formula can be used only when the number of subdivision of the interval of integration is even or multiple of 2. Okay, equal or multiple of 2. Okay, there is an example given for you where this equation is solved by Simpson's 1/3 rule. Okay, now let's start. We consider this equation as y, and we will find the value, or we will get the value of a, b, um, and also n, which we consider 6, which is the upper value of the equation, and we just find out the value of h from these given values. Okay, now we simply calculate the value of the equation, where you can see that there are two columns, one is x and another one is y, which is the equation's value. At first we consider x 0 equals to 0, which are already given in the equation, and we can find out the corresponding y0 value. Then we calculate x1, x2, x3 in this way, and up to x6, because we have the higher value of x is 6, and we get the y6 value uh, according to the formula, according to the equation. Then we calculate the Simpson's one-third rule and put all the values in the Simpson's one-third rule, and we will get our desired result. But that's all for today's week, and I hope all of you understand it clearly. If you have any problem or if you have any queries, please let me know through e-learning. And please try to join the live session so that you can understand better. Thank you all.